Albert Einstein, born on 14th March 1879, was a German-born physicist who developed the special and general theories of relativity and won the Nobel Prize for Physics in 1921 for his explanation of the photoelectric effect. Thus, this year, 2021, is the centenary year of Nobel Prize to Albert Einstein. Einstein is generally considered the most influential physicist of the 20th century. Einstein was born as the first child of the Jewish couple Hermann and Pauline Einstein in Ulm on March 14, 1879. In November 1881, Albert's sister Maria called Maja was born. A short time later, the Einstein family went to Munich, where Albert first attended elementary school and subsequently Lüttichburg Grammar School. He was an average pupil but already very early interested in science and mathematics. He did not like lessons in grammar school as they were held with strict discipline and as he was forced to learn. When he turned 15, he left school without any degree and followed his family to Milan. To make up for the missed degree, he attended school in Switzerland from 1895 to 1896, when he successfully took his A-level and began to study in Zurich. His ambition was to obtain the diploma of a subject teacher for mathematics and physics. He successfully finished his studies in July 1900. He moved to Bern and was given work at the patent office. In his leisure time, he worked in the area of theoretical physics. Life. Albert Einstein was raised in a secular Jewish family and had one sister, Maja, who was 2 years younger than him. In 1903, Einstein married Milena Mark, a Serbian physics student whom he had met at school in Zurich. They had 3 children, a daughter named Sherry and 2 sons named Hans and Edward. Awards and achievements: Bernard Medal in 1920, Nobel Prize in Physics in 1921, Gold Medal of the Royal Astronomical Society in 1926, Max Planck Medal in 1929, Member of the National Academy of Science in 1942, Time Person of the Century in 1999.
Photoelectric effect. Photoelectric effect is the emission of electrons when electromagnetic radiation such as light hits a material. Electrons emitted in this manner are called photoelectrons. The phenomenon is studied in condensed matter physics and solid state and quantum chemistry to draw inferences about the properties of atoms, molecules and solids. The effect has found use in electronic devices specialized for light detection and precisely timed electron emission. The experimental results instead show that the electrons are dislodged only when light exceeds a certain frequency, regardless of the light's intensity or duration of exposure. Because of low frequency beam at a high intensity could not build up the energy required to produce photoelectrons as it would have if light's energy were coming from a continuous wave. Albert Einstein proposed that a beam of light is not a wave propagating through space but a swarm of discrete energy packets known as photons. Let me first keep the collector plate A at some positive accelerating potential with respect to the emitter plate, that is C. Now let's allow light of fixed frequency nu and a fixed intensity I to fall upon the emitter. Now we vary the positive potential of the collector plate gradually and measure the resulting photocurrent each time. Now, as the positive potential of the current increases, as you might have expected, more and more emitted electrons will reach the collector plate. Let's plot our photocurrent against the collector plate potential and we can see that the photoelectric current increases with increase in positive potential. As you can see, at a certain point, at some stage for a certain positive potential of the collector plate, all the emitted electrons will be collected by the collector plate A and the photoelectric current becomes a maximum, or in other words, we can say that the photocurrent saturates. If we increase the accelerating potential any further, the photocurrent does not increase. Now, this maximum value of the photocurrent is what is known as a saturation current. So, just imagine what will happen if we instead apply a negative or a retarding potential to the collector plate with respect to the emitter plate. That is, we make it increasingly negative. When we reverse the polarity in this way, the electrons are repelled by the collector plate and only a few electrons that are most energetic ones will still be able to reach the collector plate, so the photocurrent will decrease rapidly. at a certain negative potential of the collector plate, you will find that all the emitted electrons are repelled by the collector and no electron in effect reaches it, and so photocurrent becomes zero. Now, if you look at the graph, the sharply defined critical value of the negative potential V0 of the collector plate is known as the stopping potential.
In physics, mass-energy equivalence is the relation between mass and energy in a system's rest frame, where the two values differ only by a constant and the units of the measurement. The principle is described by the physicist Albert Einstein's famous formula E is equal to mc square. The formula defines the energy E of a particle in its rest frame as the product of mass m with the speed of light squared c raised to 2. Because the speed of light is a large number in the everyday unit, the formula implies that a small amount of rest mass corresponds to an enormous amount of energy which is independent of the composition of the matter. Rest mass, also called invariant mass, is the mass that is measured when the system is at rest. It is a fundamental physical property that is independent of momentum even at extreme speed, approaching the speed of light. Its value is same in all inertial frame of reference. Massless particles such as photons have zero invariant mass, but massless free particles have both momentum and energy. The equivalence principle implies that when the energy is lost in chemical reactions, nuclear reactions, and other energy transformation, the system will also lose a corresponding amount of mass. The energy and mass can be released into the environment as a radiant energy, such as light, or as thermal energy. The principle is fundamental to many fields of physics, including nuclear and particle physics.
Brownian motion or paresis is a random motion of particles suspended in a medium, a liquid or a gas. This pattern of motion typically consists of random fluctuations in a particle's position inside a fluid subdomain followed by a relocation to another subdomain. Each relocation is followed by more fluctuations within the new closed volume. This pattern describes a fluid at thermal equilibrium defined by a given temperature. Within such a fluid, there exists no preferential direction of flow as in transport phenomena. More specifically, the fluid's overall linear and angular momenta remain null over time. The kinetic energies of the molecular Brownian motions, together with those of molecular rotations and vibrations, sum up to the caloric component of fluid's internal energy, that is, the equipartition theorem. This motion is named after the botanist Robert Brown, who first described the phenomenon in 1827 while looking through a microscope at pollen of the plant Clarkia purgella immersed in water.
When you change the way you look at things, the things you look at change. By being tired, I wish you all to have a great day. Special Theory of Relativity. Albert Einstein's Special Theory of Relativity is published on 26 September 1905, titled On the Electrodynamics of Moving Bodies. Is one of the most important papers ever published in the field of physics. Special relativity is an explanation of how speed affects mass, time, and space. There are two main ideas that make up Einstein's theory of special relativity. First one, the principle of relativity. The laws of physics are same for all inertial reference frames. Second one, the principle of the speed of light. The speed of light in a vacuum is same for all observers regardless of their source of light. The theory includes a way for the speed of light to define the relationship between energy and matter. Small amounts of mass m can be interchangeable with the enormous amounts of energy E, as defined by the classical equation E is equal to mc square, where c is the speed of light in vacuum. They are in fact just different forms of the same thing, and a defining feature of the special relativity is the replacement of the Galilean transformation of Newtonian mechanism with the Lorentz transformation. Time and space cannot be defined separately from each other as was previously thought to be the case. Rather, space and time are interwoven into a single continuum known as a space-time. Special relativity uses a flat four-dimensional Minkowski space, an example of space-time. Minkowski space-time appears to be very similar to the standard three-dimensional Euclidean space, but there is a crucial difference with respect to time. Today, special relativity is proven to be the most accurate model of motion at any speed when the gravitational and quantum effects are negligible. Even so, the Newtonian model is still valid as a symbol and accurate approximation at low velocity relative to the speed of light. Thank you.
In physics, a unified field theory is a type of field theory that allows all that is usually thought of as fundamental forces and elementary particles to be written in terms of a pair of physical and virtual fields. According to the modern discoveries in physics, forces are not transmitted directly between interacting objects, but instead are described and interpreted by intermediary entities called fields. Classically, however, a duality of the fields is combined into a single physical field. For over a century, unified field theory has remained an open line of research, and the term was coined by Albert Einstein, who attempted to unify his general theory of relativity with electromagnetism. The theory of everything and grand unified theory are closely related to unified field theory, but differ by not requiring the basis of nature to be fields and often by attempting to explain physical constants of nature. Early attempts based on classical physics are described in the article on classical unified field theories.